Schottky, and I'm working with neurologic bachelor vision. And we have here the shaded closed-load demo. And the purpose of this demo is to demonstrate the difference between thick film and thin film technology, using the similar solder pads for the thick and thin film technology, and highlight the superior performance of MELF resistor due to this cylindrical shape and therefore additional host capability that the component can handle. As you can see here, for the thick film technology we have this L-cut. This builds a kind of hotspot, and actually the active resistive element area is going to be, there is a kind of limitation to the post load. If you go to this meander cut of the thin film technology, the heating dissipation spreads all over the resistive element, and actually the area of the resistive element is bigger than this one. And for the MELF, using the semi-solder pads, the resistive element is even bigger than this thin film technology. And the idea of the pulse demo is to highlight this difference. How do they perform under some kind of surgery requirements? And the first component here is the non-name thick film resistor. It's a non-V-shape component using thick film technology, and we are going to apply 15 watts, as you can see here. And let's see what happens to the non-name thick film resistor. So 15 watts is enough to a resistive drift over 10%, which means that this component is no longer in working condition. Let's now switch to the V-shape thick film resistor, the CRCW 805. They have similar solder pads and similar technology, but the V-shape component are using better materials, and then they will have better performance. So you can see that the resistance value is the same. Is again a single pulse condition of 3.3 milliseconds. And now let's start applying 15 watts, which was the last pulse load for the competitor part. And for the V-shape CRCW, you can see almost nothing happens in the component, only 0.01% of drift. And now let's double the peak pulse applied to the component, and then for the CRCW, it's not too bad, it's around 0.3%, 4%. And actually applying double the power compared to the non-name thick film, we see that the CRCW is surviving pretty well. And now let's increase it to 35 watts, and then it's about the limit of this component, with the resistance drift over 100%. So the component is basically open and no longer in working condition. And now the thin film technology is the next one in our demo. As you might remember, the thin film technology has a different streaming process, which gives much better heating dissipation all over the resistive element. And this is might be the MC or the TNPW 805. New sample, same resistance value, same pulse duration. And now let's start applying 35 watts. And let's see what happens to the component. Just a small resistance drift around 0.01%. Let's double this power. And we can see a drift close to 1% on the negative side, but it's not too bad because now we are applying 70 watts, which is around 5 times compared to the non-name and twice the power that you apply to the thick film technology. Let's increase to 75. Is about the limit for this type of component, and it's already in no working condition. And now the last component that we are going to show is the mouth. So the cylindrical shape is the advantage of this component in terms of post-load capability. New sample, sorry, I need just to change here to mouth component. New sample, same resistance value, same pulse duration. Now let's start applying 75 watts, which is the limit for the rectangular thin film technology. And after 75 watts, just some small drift around 0.01%. Let's double this power, 150 watts. It's almost 400 volts. And for the mouth component with this cylindrical shape, the same solder pads of the 0805, only 0.06%. Still a very good performance for this high pulse load. Let's increase to 200 watts. The drift is, the component is almost gone. You can see minus 6%, 230 watts, and let's see what happens. You can see some arc, and then the component is gone. And actually the idea of this pulse demo, as I told you in the beginning, is just to highlight the difference between thick film and thin film technology, and to demonstrate the superior performance of the mouth with this cylindrical shape.